In this video, we're going to address the topic of note snapping.
Now, why are we having to snap notes?
Well, if you remember from the free play test we did a moment ago, whenever we're dropping notes onto the timeline, they're falling at exact tick values, whatever the cursor happened to be when we hit a drum. Now, if we jump into the game real quick, it'll be easier to show this live. Now, as we're running through the game, you'll notice that if I try to drop hi-hat notes exactly on the beat lines, if you look real close, they can get right up on the line, but not quite hit it.
They could be like 1 pixel this way or 1 pixel that way.
Exactly, just because of the resolution of our tick rate. And with the problem...
Not to mention you have a wireless keyboard, which is making it worse.
Which is inducing lag. So for the purposes of a smooth and solid feeling free play mode, what we want to do is employ a form of note snapping. The idea is to give a threshold into which the notes will snap, thereby giving a cleaner presentation.
Right.
So it's like we'll give a little bit of forgiveness on either side of a beat line to let a note snap to that location.
Right. Now, it doesn't mean that we're going to get away from accuracy altogether. We can take this threshold and make it very narrow if we'd like. We can set it eventually to a certain selection of notes. So we could snap to 32nd notes or all the way down to 64th notes if we want to. It's just some way to keep it so that we're not having to keep track of an exact tick value. We don't have to be computer accurate in our play.
Exactly. It gives a much cleaner and better feeling presentation when you're entering notes. So, to get started, let's jump into our song class. And inside of song, let's put together a method that'll let us put in a tick value and a snapping size, and then get back a tick snapped at that size. For example, if we gave a snap size of 10 ticks, we would want the tick to be returned in multiples of 10. Just like we had seen earlier when we were writing the staff rendering system, we set up those measure lines to fall on ticks that were snapped to exact measures. And we saw how, when the ticks were advancing, we began with a value of 100. We saw how the cursor was advancing by 1 tick units, and the measure lines were advancing in 100 unit increments.
Right.
We'd like to achieve the exact same thing here with our note snapping. So here inside of song, let's jump to the very bottom of the song class right below isNoteAtTick. And let's drop down a new method. Let's actually put this together as we'll follow the same thing we've been doing, an instance method, public method that will return a snap tick for the given song. So we'll put together a public method. It will return an integer because we're going to put a tick in and we want to get a tick back out. We'll call this method snap tick, and then we'll take in 2 parameters: the incoming tick value and a snap size that we would like this tick to be snapped to. So we'll have a second integer called snap size. Now, inside of this method, we want to use the same mathematical formula that leverages integer division, where we truncate the remainder, giving a result similar to the floor function. So what that means is we're going to take the tick, divide it by the snap size, and then remultiply it by the snap size. Again, this way we'll take, and it's almost like we could say that we're lowering the accuracy for tick in question.
Right.
So, very simply, we could take these values and return tick divided by snap size times snap size. And again, all of these are integers, so we will be doing integer arithmetic. Now let's jump over to our song record class, and let's put this method into use. There is going to be a few things we'll need to tweak on this formula, but we need to see them in action to know exactly what it is we're tweaking. So we'll jump over here to our song record class, and inside of press note, we grab this tick variable, the tick where we're going to drop the new note at. We're currently just copying the cursor value. But let's try instead snapping the cursor instead of just copying it. So what we'll do is we'll say tick is equal to snap tick. Again, we have access to snap tick because we are here inside of a song derived class. So we'll drop in snap tick. The first parameter is tick, so we'll drop in this dot cursor. And for the second parameter, let's drop in a value of an entire quarter note. This dot quarter note. Now again, this is a much larger snapping size than you would want to use in an actual song.
Sure.
But this will give a snap size of an entire beat, what that's going to mean is we're only going to be able to drop notes exactly on beats. If a note falls anywhere in between, it'll get snapped to a beat.
Not ideal, but it could work for a proof to make sure everything's working.
Exactly. It makes it a lot easier to see. Also, let me take the tempo that we're running the game at and slow it down. As a matter of fact, let's jump into our game screen game down here in the game folder, and let's bring the tempo down after we load up a song. So just scrolling up here till we find the reset method. Let's, for the time being, comment out the line where we're loading in a specific song, bring the beat generator back into play, and load up beat 1. And then let's turn around, because that beat is going to come in at a tempo of 120. Let's turn around and lower it. Songs sub I. And you know, thinking about it, this... Actually, no, this is the wrong class to set this in. This is the game screen. We're working on the free play screen, so that's not actually going to take effect.
Whoops.
So we'll patch that back up. Inside of screen free play, yes, this will make a lot more sense too, because thinking about it, we have to manually set the tempo to a recording tempo. So we'll simply pull that out and set a value that is lower. We'll set our BPM to a value of 60. That'll just give us more time to watch the beats go by and to test hitting notes in between beats. But again, the key change here is now song record is snapping the cursor before it assigns it to a tick, which eventually gets assigned to a note. And again, this check here is now much more important, the is note at tick check, since it'll be very easy to hit the same note over and over again, since we're snapping to that beat as long as we're on the same beat.
You have like at least a full second to put it all in one location.
So let's jump in and jump into free play. Here inside of free play, we'll let the first measure advance. Then if we hit a hi-hat, you can see it's now snapping back to the beat we just passed.
Yeah, even though you're already beyond the cursor, it's snapping it backwards.
Now, that makes sense if we're really close to it. If the beat we just passed is closer than the upcoming beat, that would make sense.
Yeah.
But what happens if we wait till just before a beat?
You notice it's snapping way back to the last beat we crossed almost a full second ago.
And this is, again, because of the formula we're using for snapping. We're saying that unless we fully advance to the next snap size threshold, we're going to always snap back to the earliest tick.
So it's almost like truncation. It's just taking whatever remains after that and just chopping it off, and you end up going backwards.
Exactly, and that's exactly what's happening with the integer arithmetic. Now, naturally inside of the drum game, in order to make things look correct, we would rather snap to the nearest tick, or the nearest beat.
So like if we're beyond the halfway point, we want to go up to the next one.
Right, exactly. So go to whichever one is closer, not whichever one is within the last truncation threshold. Now, in order to show what we need to do, basically we need to do an offset. We need to take some of our tick values and shift them a certain way. Basically, in this case, if you think about taking our snapping and shifting the whole thing forward some, like let's say you took half of the snap size and shifted forward, that should center nicely.
So you're saying leave the snap size exactly what it is right now, but if you shift it forward halfway, then you're going to be able to round at that midpoint.
Right, because if you took the exact values we're getting now and just moved them forward some, then you would start landing on both sides of the beat. Now, in order to show that in a more visual manner, let's bring up a new temporary console app and demonstrate the values that should end up getting returned. Because it's all well and good to talk about the values that should appear, but it would make a lot more sense if we could just see the incoming tick values and the resulting snapped values. So let's grab a new instance of Visual Studio and begin a console project. We'll jump back up here to Visual C#, grab console application, and hit OK.
Yay, console app demo time.
So we're going to use a very simple console app just to give ourselves some example snappable values and show what the offsets would end up doing. All right, before we jump into the main method, let's put together a snap method to mimic what we had just done over in our drum game. Let's put together a static method. We'll return an integer, and we'll call this method snap. We'll take in an integer called tick and an integer called snap size. And inside of this method, we'll do the exact same thing we did earlier. We will return the tick divided by snap size, then multiplied by snap size. Alright, so we've got a method that can return ticks. Now we need some type of sampling code. We need to go through a series of numbers and then snap all of those numbers so that we can compare them. So here inside of main, First, let's drop down a snap size. We'll say that, for example, we're going to try snapping to a tick value of 5. So we'll set snap size to be 5. And now let's put together a for loop so it could go through the integers maybe 0 through 23. So we'll say for local variable I loops until we hit just before 24. The reason we're using 24 here is our console window by default is going to be a size of 80 characters in width by 25 characters in height, and we don't want to hit that last line of characters, otherwise we'll cause the console window to scroll.
Oh, okay. I was trying to figure that out. I was like, why 23?
So we're going to set a number of characters that will stay completely on screen.
Gotcha.
Alright, as we're going through this loop, let's simply print values out to the screen in order to sample them. So we'll grab a console.writeLine call, and we'll put together some string formatting for our example values. We'll say that, to begin with, let's show 2 arguments, the tick by itself, which will be I, and the snapped tick. So we'll begin with argument 0, and we can say space, and then argument 1. Now we feed in the values I, representing our tick, and then the snap method call result of the tick value I and the snap size given in snap size. So that should take care of our call. Let's hit, if we hit F5 right now, we'll probably fall right back out into Visual Studio. Let's hit Control F5 to run without debugging, and that way we should dump out here and leave the console window open. The other option we would have would be, of course, to do a console.readline in order to hold up execution.
Sure.
Alright, looking at the values we're getting, these are making sense and compared to what we were seeing back in the drum game. Watching the values advance 0 through 4, we're getting all zeros. So we haven't yet reached a high enough value to roll over to 5. The moment we hit 5, our snap value changes to 5 and remains so until we hit 10. But looking at what that would mean, let's say, for example, our beat value was 5 ticks.
Yeah.
If we were watching this, we'd have a beat at 0, then at 5, then at 10, and so on.
It's kind of like we're snapping backwards just by a finer grain.
Exactly. Yeah, this is exactly like taking the snap size and just lowering our ticks per beat value.
Yeah, we still have the same problem, we just have a lot more of it now.
Exactly. And that just makes it more clear on screen here rather than snapping to 96 or greater ticks.
Right.
But looking at what's going on, you see that we have to get all the way up to 10. So that means, mimicking like what we were seeing in the drum game, if we were at tick values 8 or 9, we're still snapping all the way back to 5 instead of snapping up to 10. Now, another way you could look at this is if we were to take this entire column and shift the right column down. In order to make that a little bit easier to see, let me pad these columns out a little bit, because of course we're getting into double digits and then moving all of our text over. It would make it easier to see if we dropped in here and inside of our formatting said argument 0, 5 to give ourselves a column width for this argument. And the same thing for 1. So inside of the braces, 1, 5. And that should give us 5 characters of width for our columns. I'll hit Control F5 again, and now our columns line up much more nicely. So if we're looking at these values, starting with the block of 0s, block of 5s, block of 10s, and so on, if we just took this block and moved it down, even by maybe just 2, then we would end up with a scenario where we'd have 5 reaching past, in this case, our 10 value. Actually, we'd want to go the other way.
You're going to slide it up.
Yeah. Looking at that, yeah, it would be backwards.
Yeah.
If we took this entire column, let's say 5, and shifted, let's say 1, 2 up, so we'd have 5, so 3 would snap to 5, 4 would snap to 5, 5 would then be centered on 5, and that would make sense. Now, in order to cause the snapping threshold to snap backwards, we need to take this tick and actually advance the tick forward, meaning that when we go to calculate 3, we actually advance it to 5 first and then apply the snapping, and that way 3 would resolve to 5. So we need to take our actual tick forward in order to make our snapped result appear to move backwards.
Sure. You're just kind of sampling ahead in time.
Exactly. So in order to do our sampling ahead, we'll take our tick value and we will offset it by snap size divided by 2, so half of the snap size. Now we'll take this entire operation, or part of the operation, and drop it into parentheses. Make sure we get all of this taken care of first before we apply the actual snapping, division, and multiplication. Now if we jump into our test again, we can see that the values 0, 1, and 2 snap to 0. 3, 4, 5, 6, and 7 all snap to 5. So there you can see one value of 5 centered on this value.
Yeah.
So 5 leading up to it and leading out of it, and the same for all the others. So that means if we were on ticks 8 or 9, we would snap up to 10.
You have a much more intuitive snapping system taking place now.
Exactly. So visually it makes more sense that anything along this line you can imagine getting funneled down into the value 10.
Mm-hmm.
All right, let's take this addition to our formula and put this in place inside of the drum game. So switching back over to drum game and then over to the song class, here we have our snap tick method, so let's do the exact same thing. Let's take tick and offset it by snap size divided by 2, and then the result of our offset with tick, we'll divide that and multiply it against our snapping. And now let's jump into the game and closely watch what happens when we drop notes down. So here inside of free play, we'll get past the starting marker and begin hitting ticks. Now you notice if we're doing the same thing we had before, if we get just past the beat, we're still snapping backwards. But let's wait for a beat line to come up right before the cursor.
And now we snap forward.
So now we can indeed see that the snapping is going to the nearest snap size rather than the last snap size.
Nice.
You'll also note if I hit the key faster than the actual tick rate, we're only hearing one hi-hat per hit.
Because we're still doing that check to see if a note's already there, and if it is, then we're not adding one.
Exactly. So, now we have some solid snapping code, a solid snapping formula for our game. Before we leave off of this video, let's clean this up a little bit and make it easier to use and to configure. The first thing we'll do is back in here inside of song, let's also give ourselves the ability to snap by a note value in addition to a raw tick size. For example, it'd be nice to say that, we want to snap in terms of eighth notes.
Sure.
So take an eighth note value and make that our snap size. Or maybe a 32nd note, make that our snap size. So let's jump here inside of song and let's make a second method. We've already made snap tick, so let's make a method called snap note. Make a public integer method, snap note, and then we'll take in the same types of parameters, an integer called tick and an integer called snap size. Now what we need to do inside of snap note is figure out what the note value would be. As a matter of fact, snap size doesn't make sense in terms of a note. It's too generic sounding. Let's change that to note.
Okay.
So you could say note, note value, basically something to indicate the note denomination.
Okay.
Now, what we want to do is take this note value and figure out how many ticks are represented by it. So what we'll do is we'll formulate a snap size here inside of snap note. So we'll make a local integer variable called snap size, and we'll set that to be equal to the quarter note value. Let's step from a quarter note, we'll step all the way up to a whole note, and then if we're sitting at a whole note's worth of ticks, then we can easily divide by the number representing the note. So if you take a whole note divided by 16, so you get a 16th note, and so on.
Right.
So I'll say that the snap size is equal to this dot quarter note. Again, that's the number of ticks in a quarter note. Multiplied by 4 would be the number of ticks in a whole note. Divided by our note value would give us the specific number of ticks for this note. Now, one thing we do want to do before actually progressing into this, because we're doing divided by note, and there's the possibility that a user could try plugging in a value of 0, and then we'd be dividing by 0, attempting to find the note value. So in the case that note is 0, let's simply return the current tick, because again, snapping to a note span or a note denomination of 0 wouldn't make sense. So rather than fail out with an error message, let's just give the tick back to whoever requested it. So if note is equal to 0, then we'll turn around and return the current tick. Again, this just prevents problems with the division.
Okay.
Alright, now that we have found a snap size, let's also make sure that our snap size, again, since inside of snap tick, snap size is actually used within division as well. Let's also make sure that this resulting snap size doesn't end up being 0. So we'll take our snap size and make sure that it is at least 1 before using it. So snap size will be equal to math.max
Between itself and 1, I guess.
Yep. So snap size and 1 as values 1 and 2. So we're saying if the snap size value is greater than 1, then perfect, we'll just retain snap size. If 1 is greater than snap size, for example, we got a negative or 0 value, we'll use 1 instead.
Gotcha.
Now that we've got a snap size value formulated and checked, let's apply this using the snap tick method. At this point, we're ready to build the return statement for our snap note method, and the value we will return is snap tick, where we pass in the current tick. Again, this is just a pass through snap note itself, and snap size is the variable we've just assembled.
Gotcha.
So really, snap note is like a wrapper to snap tick, where it takes in a note and calculates the tick value before using the formula inside of snap tick. Alright, now that we've got a convenient way of using note values for our snapping values, let's make this value configurable inside of our config system. That way we'll have a way of configuring the granularity of record mode outside of the game itself. So let's bring up our config file. Up under content, let's grab our config XML file, and let's make a new setting. Here, right below our default recording tempo, let's make a second node. We'll make an option called recording granularity. And we'll give a value attribute, which we will set to begin with 4. And this will match the debug value we're currently using. This is saying that our recording granularity is going to be a quarter note. So we'll have the same every beat snapping range. Now we need to go into our config class. If we jump down to game, we can bring up config.cs, and we need to put this new value into place as a field. So let's start with one of our existing fields. If we took our existing default recording tempo field and duplicated that, we could create the field for recording granularity. Then inside of our load options method, we'll load recording granularity into its field.
Gotcha.
So we'll say that recording granularity, and let's actually specify this with a capital letter. Drop in, hit F2 to refactor this to capital recording granularity to fit the naming scheme we have here inside of config. Recording granularity will be an integer value, so we will continue to use parse int. And the option that we are looking for is recording granularity. Alright, once again, as with all of our new fields, we will do a very quick test of the configuration code. We'll set a breakpoint on recording granularity, run the game, fall out to the breakpoint, recording granularity defaults to 0 until we step over the line and we load in the value of 4.
Nice.
So, with our option loading in, let's now put this recording granularity option into use inside of song record. Back over here in song record is the place in which we are using our snapping method. Now let's change this method to, instead of using snap tick, let's use snap note. And then for the note to pass in, we'll drop in the value found in the config class.
Recording granularity.
And that's exactly what we need. We'll drop in recording granularity. That will be used to feed in our tick. And let's see. Looking here, let's go over to screen free play. And let's also do a check and see whether or not we should drop the current note. Actually, no, let's test this first. Let's jump in here and make sure that we're still getting the same result before we go forward. So as we drop our notes, we can drop them on the nearest tick line.
See them jumping forward and backward.
So, very nice. Now what we want to do is, since we have verified that all of this is working properly, let's jump into our config and lower our granularity down to a 30-second note size. So back here in config.xml, let's drop our recording granularity down to 32. So we'll snap to 30-second notes instead of quarter notes. Now we'll jump in and run the game. So now as we're dropping notes down, you can see that we can get mini notes in between our tick measures. Now, one last thing to show, and that is, let me briefly set our recording value back to 4. There's one problem where, watch what happens as we're progressing or getting closer to our start line. It's very difficult to hit exactly on the start line if we get just past it. So let the start line pass. Then it may be a little bit tricky to see here because it'll sometimes fade over to it. But there's a small offset that we can place to make sure that we can still hit that starting line.
Okay.
Because right now, if we look at the code, it'll make it a little bit easier to see that here inside of input pressed, we're saying that the song's cursor has to be less than, or if the song's cursor is less than 0, then we'll fire off this method. Now, what if we were within the snapping threshold before the cursor? We would want to be able to still hit that note. We don't want to have to wait till we get exactly to the start line before snapping a note to it. So what we'll do is we'll make sure that the cursor itself is out of snapping range before we play the sound. So instead of just checking the cursor, we'll instead check, actually we'll pull this out, and begin with our current song, for song.snapNote. We'll give in the tick of song.cursor, and the snapping threshold given in config.recording granularity. If that resulting note is less than 0, then we'll fire off the sound. So basically we'll run the snapping code first.
Okay.
And that way, let's say we had a tick value, if our snapping was, say, 4, so entire quarter notes, and we were only 3 ticks away from our cursor, then that would end up snapping up, because of our offset, to 0.
Okay.
And therefore we wouldn't fall into our click sound trap. We'd fall out to press note. So we'd allow a note to be pressed right before the cursor is actually playing.
So really what you've done is you've set up a way that we can go ahead and drop something down on the start line by actually hitting a note just before the start line approaches.
Right. So with our snapping value should still be set to 4, let's jump in and hit a note right before the snapping cursor comes up.
There you go.
There, and so the note actually jumped a little bit forward to hit that line. But that way we snap, it's almost like you could say centering up the snapping on the start line as well.
Yeah, because prior to this, if the start line hadn't made it to us yet, we can't put a note there. The start line has got to be right underneath the cursor or just beyond it, and that can be a little bit tricky.
Exactly, and then the result is to a player is it makes it feel like the start line is a little bit flaky, because then they can feel like they hit a note almost dead on. They could be within 1 tick of the start line, and the game would end up rejecting the note.
Right.
So with this in place, we have a more friendly snapping method so that the first start line can be hit the same as any other note in the game.
All right.
Now, before we end off, let's set our snapping value inside of our config file back up to 32. We'll use a value of 32nd note for our free play mode. And again, we saw how with that we can place lots of notes in between all of our beats. So we'll make sure that all of this gets saved out. And with that, we have accomplished snapping inside of the game. We've given ourselves the ability to snap 2 notes, and we have made sure that everything is cleaned up for use of our snapping code. So with that, that's going to wrap up this video.